Hello, welcome to week 6, the final week of the GCSE Physics Summer School with Physics with Keith. This week's all about gases. You see, I've chosen a few questions, 5 questions here. I went for fewer questions in case there were any of the questions from the previous 5 weeks that you wanted to have another look at. It gave you a bit more scope to do that. So let's go through some tips for each of these 5 questions. Question 59.1 needs the equation pressure equals force divided by area, where force is in newtons and area is in cubic square meters. Then the pressure will be in pascals. But you're going to have to be careful because part of the question involves converting square meters to square centimeters or the other way around. You've got to be a bit careful here, because whilst 1 metre is 100 centimetres, 1 square metre is not 100 square centimetres. And if you try to visualise this, it makes sense. If I take 100 small pieces of string, each one 1 centimetre long, and line them up end to end, the piece of string will be 1 metre long. But if I take 100 little squares, 1 centimetre by 1 centimetre, and lay them out, it is not going to cover an area equal to 1 metre by 1 metre. Nowhere near. Now the word centi in centimetre means a 100th. And that's why, if you look at the first part, where we're just converting lengths, 100 times the centi, which means 100th, 100 times 1/100th, the hundreds cancelled, you're left with 1, and that's what 1 metre is. So the usual unit conversion things works here. The reason why it's a bit more tricky with areas and with volumes is because the centi part is also squared. And so you can see that 100th times 100th is 1/10,000th. And let's just write this down, centi squared equals 1 2 3 4, 1/10,000th. And 100 times 1/10,000th is not 1. In fact, it's 10,000. And it's 10,000 because 10,000 times a 10,000th, which is what centi squared is, a 100th times a 100th, that's equal to 1. So now you know how to convert your areas. And with volumes, you do a similar thing, but the centi would be cubed. 59.10 is going to ask you to convert temperatures from degrees Celsius into Kelvin and from Kelvin into degrees Celsius. And the conversion is, as you can see on the screen here. To convert from degrees Celsius to Kelvin, you add 273. To convert from Kelvin to degrees Celsius, you subtract 273. Couldn't be easier. 59.7 is about Boyle's law, which is what happens to ideal gases when you have a constant temperature and nothing else changes. What I mean by nothing else changes, you've got the same amount of gas, constant temperature. So if you increase the volume, you decrease the pressure. And if you decrease the volume, you increase the pressure. But more than that, the factor change in the volume is the reciprocal of the factor change in the pressure. So if you double the volume, you halve the pressure. If you halve the volume, you double the pressure. If you quarter the volume, you times the pressure by 4. And if you times the volume by 4, you quarter the pressure, and so on. They are inversely proportional. So you figure out the factor change, and then you take the reciprocal, and there's usually a button on a calculator that says something like 1 divided by x, or it might say x to the negative 1. You press that button to take the reciprocal of that factor change, and then you multiply that factor change by the other variable to find out what the new variable is. 60.3 uses the pressure law, also called Gay-Lussac's law, although there is some sort of controversy about whether it was Gay-Lussac that came up with it or not. So the pressure law is where we assume a volume is constant and pressure is directly proportional to temperature. But be careful. The temperature in this question must be in Kelvin, or it will not work. If you do not use Kelvin temperature, you will get the wrong answer. So once you've converted your temperature into Kelvin, find the factor change in the temperature, and that will tell you the factor change in pressure because they're directly proportional. Then you multiply the old pressure by that factor change to get the new pressure. In fact, 60.1 uses exactly the same ideas. And that's it. That's all there is for this board. The idea, as I mentioned at the start of this video, is that you'll go back and you will have a look at any of the previous questions that you wanted some help with. And it also gives you an opportunity to ask me for help with anything else that you might be concerned about in terms of physics. So I will see you next Saturday at 10 AM for the final GCSE Summer School session. See you then.